Bismillahirrahmanirrahim. Moving to the next topic, which is the nuclear stability with the different decays, radioactive decays. We have already discussed the different decay process, and now we are going to discuss the nuclear stability by using the different decay, radioactive decays. So objective, as mentioned over here, is what type of radiations should radioactive nuclides emit to get themselves stabilized. So this is the objective. Actually, now we are going to apply the previous knowledge to discuss this stability, because if the nuclide is radioactive, and of course, if the nuclide is radioactive, then they can emit any type of the radiation, and this may be the alpha decay, beta decay, gamma, positron emission, or the electron capture. This is beta decay mean, this is the neutron emission. So these five different decays we have discussed in the previous videos, and there are these certain changes in the atomic number or the mass number, and these are the representation, and where the parent is converted into the daughter, and this is also shown by the nuclear equations. So again, if you need any further clarification, please watch individual videos. And here we are going to apply this one knowledge to discuss the nuclear stability. And I am going to plot the graph between the number of protons and the neutrons. And this may be on the x-axis or this may be on the y-axis. It depends what type of the graph you want to plot, but there is no difference between this plot to this plot. So somewhere this is plotted, and some books this graph is mentioned. So that's why I have put all together. So there should not be any confusion. So first, let me to introduce what is happening over here between the relationship between the number of protons and the neutrons. So as we have already discussed right from the starting, this is the line which is coming out, passing through, let's suppose the origin, or coming out from here, which is representing that the ratio between the number of protons is neutron is 1:1. So this solid line representing the ratio between the protons and the neutron is 1:1. When 1:1, this line should be followed. But practically, look at the values. This is around atomic number 10, because this is the protons. Protons are the atomic number. Up to atomic number 10, the ratio between neutron and the proton is 1:1. But when you go beyond, then there is increase in the number of the neutron as compared to the protons. So this is the natural phenomenon. So that means these solid line, this zigzag line with the black color are the nuclide, or you can call them the stable nuclide. Because this is a natural phenomena, the number of neutrons must be greater than the number of the protons to overcome the repulsion between the positive charges. So that's why the number of neutrons must be greater than the number of the protons. So this is the stable nuclides, and the nuclides which are present over here in the different colors, in the blue colors, or this is the yellow or the brown colors, these are the unstable nuclides. So here I am going to discuss with you if what would be the possible emission of the radioactive decays if the nuclides are unstable. So these nuclides are the unstable, these nuclides are the unstable. Let's suppose if one of the nuclide is present over here, this is the unstable. If this nuclide is present over here, this is the unstable. So in brief, the nuclides which are present above this stability line and which are present below this stability line are unstable. And if they are unstable, then they must emit some sort of the radiations. So what type of the radiation they will emit? So first, let's suppose the first one, what would be the beta positive. So again, this is just the opposite relationship because this is a proton and neutron over here, and I am just keeping one of the graph. So this is the similar behavior over here. So if the nuclide is present over here, if it is, that means it is below the stability line, then it is having the more protons, because here on the x-axis are the protons, and if you consider this plot, then again this is the same, this is having the more number of the protons. So this and this is the same, just there is the reverse relationship between the plot between the protons and the neutron. So again, I am just considering one representing the alternative over here, so you can compare by yourself. So if a nuclide is present below the stability line, and below the stability line mean if the graph is plotted between the proton on the x-axis and neutron on the y-axis, then what is the possibility? It should emit the positron. Why it should emit the positron? Because positron, in the positron, protons are converted into the neutron. So when they emit the proton, that means with the emission of the proton, they will going towards the stability line. They will reach at this point. When they reach at this point, they they will be stable nuclide. So now what would be happening in case of the negatron? Negatron, that means if the nuclide is present above the stability line, again above, when you I say above, then you must mention the axis over here, the number of protons on the x-axis and number of neutrons on the y-axis, because here the case would be the reverse, and even you can explain this or this. So if it is present above the stability line with the number of neutrons on the y-axis, that means now the number of neutrons are more, because here there are the number of neutrons, and then they should emit the negatron, because in case of the negatron, neutrons are converted into the proton. There is decrease in the neutron and increase in the protons. So they will reach towards the stability line. That's why they will emit the negatron. So now consider the electron capture, and electron capture is the same as in case of the positron emission, and because in this case also protons are converted into the neutron, there is decrease in proton and increase in the neutron. So if the nuclide is below this stability line, they must emit the electron capture, and by emission of the electron capture, they will move towards the stability line, and when they reach at this line, they would be stable unless they will be emitting the electron capture or the positron emission. So alpha is left, and in case of the alpha radiation, and you know that in alpha there is decrease in 2 atomic number and the 4 mass number, or there is decrease in 2 protons or the 2 neutrons. Similarly, they are decreasing the number of protons and the neutrons with the same quantity. So what would be actually, the nuclides are going to be stabilized with the emission of the alpha radiation. Now, if it is having the more atomic number or having more instability, and they are present on the top of this stability line, that means if they emit the alpha radiation, they will move towards the stability line, because above this line all are the radioactive nuclides. So with the emission of the alpha radiation or the alpha decay, the nuclides will emit both the neutrons and the protons, and they move towards the stability line. When they arrive over here, the nuclide would be the stable. So the last and fifth one is the gamma radiation, and with the emission of the gamma radiation, there is no change in the atomic number and the mass number. So if the nuclide may be at anywhere over here in the stability line, they are just unstable due to the excess in the energy and this due to the gamma ray energy. When they emit the gamma ray energy, they would be stabilized, but they will remain at the same position because there is no change in the atomic number and the mass number. So right now we have discussed the different radiations, and then through this lecture you will understand what type of radiation they should emit. That means the radioactive nuclide should emit to get themselves stabilized, and this is the way for the emission of the different radioactive decays. So this is all about our today lecture. These are the different book I have already shared with you.